Welcome to This Explainer. Look, if you're a focused learner trying to cut through all the noise and figure out exactly what it takes to genuinely master artificial intelligence, well, you're in the right place. Today, we're unpacking the ultimate blueprint for building your very own AI skyscraper. We're going to map out the entire journey for you, starting from pouring the essential Python concrete at the very bottom, all the way up to constructing a highly advanced generative AI penthouse at the top.
Okay, let's just dive right into this roadmap. We have 5 critical phases of construction: laying the AI foundation, classical machine learning, deep learning in networks, generative AI and LLMs, and finally, enterprise deployment and MLOps. Understanding this structural flow is absolutely vital before we even think about breaking ground.
So, Phase 1, laying the AI foundation, programming, data, and mathematics. I literally cannot stress this enough. Without a rock-solid bedrock in code and math, any towering AI ambitions you might have are just going to collapse. You simply can't build a skyscraper on sand.
To lay that foundation, we need to gather our raw materials. Python is your absolute workhorse here. You've got to master its loops, data structures, and object-oriented programming. But, it doesn't stop at just writing code. You need professional developer workflows using Git and GitHub to manage your versions. Then we get to the data itself. Getting comfortable with Pandas data frames and NumPy arrays, alongside querying relational databases with SQL, gives you the power to actually manipulate the data that will eventually feed your AI. And finally, visualizing all that with Matplotlib and Seaborn, that lets you actually see the patterns you're about to model.
Now, I know what you're probably thinking. Math. But what's truly fascinating is exactly why you need it. You aren't just learning calculus or linear algebra to pass a test. Linear algebra, vectors and matrices, is exactly how AI structures and represents data under the hood. Calculus, specifically derivatives and the chain rule, is the literal gravity holding your neural networks together through a process called backpropagation. And probability and statistics? Well, that's what allows your models to navigate uncertainty and make actual reliable predictions.
Once that concrete foundation is poured, we move straight to Phase 2, classical machine learning, the structural steel framework. Think of this as erecting the steel beams of our building, where we start making our very first predictive models.
Building this framework follows a really logical step-by-step pipeline, heavily relying on the core library scikit-learn. Step 1 is pre-processing. That means scaling and encoding your data so an algorithm can actually digest it. Step 2 is supervised learning, where you give the computer the answers and it learns the patterns, using tools like regression or random forests. Step 3 is unsupervised learning, where algorithms like k-means clustering find hidden groupings in the data completely without human guidance. And finally, Step 4 ensures our framework is safe. Rigorous evaluation and tuning using metrics like ROC-AUC and techniques like cross-validation. This guarantees our model is actually accurate and not just guessing.
Okay, now we hit a massive leap. Going from classical machine learning to deep learning is a real game changer. Classical ML requires highly structured data. Think neat rows and columns in a CSV, and requires you to manually engineer the features you want the model to pay attention to. Deep learning, however, it handles messy, totally unstructured data like raw images or massive blocks of text. It uses complex, multi-layered architectures built in PyTorch or TensorFlow to extract those features entirely on its own. It's brilliant.
And this brings us perfectly into Phase 3, deep learning and networks, wiring the skyscraper's nervous system. If classical ML is the steel framework, deep learning is wiring up an incredibly complex, multi-layered nervous system.
So the absolutely crucial concept to understand here is backpropagation. This is the beating heart of deep learning. It's the mechanic where neural networks calculate their errors using loss functions. And then they literally work backward to adjust their internal weights and biases. When combined with activation functions like ReLU and softmax, backpropagation dictates exactly how our digital perceptrons learn from their mistakes to get smarter over time.
Now, depending on what your nervous system needs to do, you're going to use different specialized branches. For visual classification, like recognizing faces in a photo, we use computer vision and convolutional neural networks, or CNNs. For processing language, we use natural language processing, transforming text into word embeddings. And for processing data over time, like speech or stock prices, we use sequence modeling with RNNs and LSTMs. Oh, and across all of these, we apply optimization techniques like dropout to prevent our models from just memorizing the data instead of genuinely learning from it.
But before we go any further up our skyscraper, let's just pause for a second. Think about this. How do we go from merely recognizing data, like classifying an image of a cat, to actually generating new, coherent, seemingly human thought? The answer to that question brings us to Phase 4,
generative AI and LLMs, the high-tech penthouse. Welcome to the absolute cutting edge of the AI landscape today, where models generate completely new content.
Let's see how this all builds on what we just talked about. The Transformer architecture is the revolutionary engine powering every single modern large language model you've heard of. By utilizing a mechanism called self-attention, Transformers can literally weigh the importance of every single word in a massive data set against every other word. This allows them to deeply and accurately understand context in a way previous models simply couldn't touch. To build up here in the penthouse, you need a specialized toolkit. You can leverage commercial APIs from giants like OpenAI or Anthropic, or, if you want, run open-source models locally using tools like Ollama and the Hugging Face ecosystem. But honestly, the real magic happens when you tie it all together. You use orchestration frameworks like LangChain or Llama Index to act as the conductor, managing the flow of information between your LLM and your vector databases like Pinecone or ChromaDB, which effectively store and retrieve text embeddings for you.
Because unlocking true enterprise value isn't just about chatting with a basic model. No way. It comes from grounding these models in your own private data using Retrieval Augmented Generation, or RAG. It comes from deploying autonomous agents that can intelligently route tasks, use calculators, or even search the web. And it comes from fine-tuning open-source models using efficient mechanics like LoRa to make them hyper-specialized for your exact business needs.
Which brings us to our final phase, enterprise deployment and MLOps, the building management system. Because let's face it, a high-tech penthouse is completely useless if nobody has an elevator to visit it, right? MLOps is what keeps everything running smoothly in the real world.
Shipping AI means taking your brilliant models and turning them into accessible, reliable products. First, you build API-serving endpoints using FastAPI or Flask so other applications can actually talk to your model. Second, you use containerization, specifically Docker, to neatly package your code, runtimes, and system tools into a portable little box. And finally, you deploy those containers onto cloud infrastructure like AWS, Google Cloud, or Azure. This ensures your AI can scale safely and reliably to thousands or even millions of users.
And there you have it, the complete architecture, from absolute zero to enterprise deployment. It is an incredible amount of information, for sure, but as you've seen, it's deeply structured and highly logical. So I'll leave you with this. Where do you currently stand on this blueprint? And what is the very first step you'll take today to conquer the overwhelm and start pouring your own foundation? Thanks so much for joining me on this explainer, and hey, happy building.